plastic industries. So we can actually use metal. Hello, welcome. Let's look at this number 1 question for chemistry for WAEC 2018. Which of the following raw materials is used in the plastic industry? Option A, ethene, B, methane, C, sulfur, D, hydrogen. So what is the answer? The answer is ethane. Why? Because when you check your textbook for the uses of ethene, you will find out that one of the uses is as a raw material for plastic industry or industries. So we can actually use methane as a raw material for plastic industry because it is an unsaturated hydrocarbon. Another very important use of ethane is that it is used to hasten. If you want to hasten the ripening of fruits, if you want your mango or your orange to ripe faster, you can use ethane for that. So ethane can be used to hasten the ripening of fruits. So ethane can be used to hasten the ripening of fruits in agriculture. So that is one of the agricultural uses of ethane. So note that ethane, for this very use, ethane has to be in low concentration. It has to be in low concentration for it to be used in this way. So you can actually find this very topic in organic chemistry. So if you check organic chemistry under ethene or under alkanes, ethene is one of the alkanes. So if you check alkanes and check uses of ethene, you're going to see this as one of the uses. So take note.
Listen, how are you?
Please make sure you hit the subscribe button on the side of the screen so that you can always get our questions. Please, if you have any challenges, please drop it on the comment section. As I said before, which of the following raw materials is used in the plastic industry? Option A, ethene, methane, C, sulfur, D, hydrogen. The answer is ethene because unsaturated hydrocarbons, that is hydrocarbons with double bonds, are normally used for such reasons. If you check your textbook under the uses of it, you're going to be able to see that it is used.
Blessing. Put yourself on mute. Please.
Hello, let's look at the number 2 question. Which of the following organic compounds can undergo both addition and substitution reaction? Option A, pentane, B, benzene, C, propane, D, hexane. The answer is B, benzene. Why is B, benzene, the answer? Because the chemical property of benzene is that it undergoes substitution reaction as well as addition reaction. So when you check the textbook for the chemical properties of benzene, you will be able to see that the two properties that it has is number one, substitution reaction, and number two is addition reaction. In substitution reaction, actually, benzene reacts with chlorine, can have benzene reacting with chlorine to form chlorobenzene. So that is a substitution reaction. Whereas for the addition reaction, you can have mixtures of benzene vapor and hydrogen passed over nickel catalyst at 180 degrees. So when you have mixture of benzene vapor and hydrogen passed over nickel catalyst, it has to be over nickel catalyst, and a temperature of 180 degrees, you can have what we call addition reaction, and this gives a chemical known as cyclohexane. So check your textbook under organic chemistry, specifically under benzene. Check chemical properties of benzene. You see that these two reactions are the types of reactions that benzene take part in. So the answer is benzene. And why is it possible for benzene to undergo such reactions? Because, very, very importantly, it is unsaturated. Benzene is an unsaturated hydrocarbon. So we have to take note of this. Yes, let's look at question number 3. Which of the following equations represents a redox reaction? Which of the following equations represents a redox reaction? The answer is D, and we're going to find out why D is the answer to this question. Now, what is a redox reaction? In a redox reaction, what happens in a redox reaction? In a redox reaction, oxidation involves loss of electrons, while reduction is a process involving gain of electrons. So, an oxidizing agent is a substance which accepts electrons, and a reducing agent is one that donates electrons. So if we check out this equation, if we check out the equation where we have 2H2S plus SO2 to give 2HO2 plus 3S. Now we are going to check the oxidation state of sulfur in this, or oxidation state of sulfur in this, and now check what it becomes here to see whether there is reduction or addition. Now, sulfur in SO2 has the oxidation state or oxidation number of 4. So that is the oxidation number of sulfur in this. Whereas sulfur in 3S, that's sulfur here, has the oxidation state or oxidation number of 0. So with this you can see there is decrease from 4 here to 0 here. Because of that, we can say that there is redox reaction. Once there is change in the oxidation number of a particular element, you can say that there is a redox reaction. Hello, welcome. Let's look at this question. The process of extraction of iron from its ore is option A, decomposition, B, oxidation, C, reduction, D, sublimation. The answer to this question is actually reduction. Now, why is it reduction? It is reduction because iron ore is reduced to iron by carbon 4 oxide, or carbon 2 oxide actually, formed by the action of carbon 4 oxide on white coke in the extraction of iron from its ore. So the answer is actually reduction, and it can be found in Iron and its Compounds chapter in your chemistry textbook. So we know that iron ore is reduced to iron by CO, which is carbon monoxide. And this CO is actually formed. This is the process of extraction of iron from its ore. This CO is formed by the action of CO2, which is carbon 4 oxide, on white coke in the extraction of iron from its ore. So the action is actually a reduction, and this can be found in the chapter for iron and its compounds in your chemistry textbook. So when you have your furnace So inside the furnace, there are reactions going on. So when you have your CO2 reacting with white coke, you are going to get what we call CO. And it is this CO that will react with your iron oxide, reducing it. This iron oxide is actually called hematite, that will now reduce it to ordinary iron. So that's how you go about getting your iron, because of the reduction of this iron ore, removing this oxygen to give you only iron, which is what you actually need. So this reduction of this iron ore to ordinary iron is what we call, is how we go about extracting our iron from its ore. And that's why the correct option here is reduction. So please take note of this. This is what happens in this furnace. Okay, so there is a reaction between CO2 and white coke to give CO. So this CO reduces your iron ore to ordinary iron. So that's why that is the answer. Please, if you like this, hit the subscribe button by this side of your screen. Support us in any way that you can. Thank you and God bless you. Also know that the ore for iron is hematite. Very, very important. The name of this iron ore, this very iron ore, the name is hematite. So take note. So this iron ore is reduced by CO, which is carbon monoxide, to ordinary iron. And how do you get this CO that reduces it? You get it by the action of CO2, which is carbon dioxide, on white coke to get this CO. So this CO reduces this to iron. So take note, that is what actually happens. Please hit the subscribe button. Thank you and God bless you.
What? Still searching YouTube for math help? Are the videos from 2006 really?
Welcome. Let's look at this question. What is the solubility of a salt if 0.4 gram of it is obtained on evaporation of 200 cm cubed of each saturated solution to dryness? Option A, 0.8 gram per dm cubed. B, 2.00 gram per dm cubed. C, 8.00 gram per dm cubed. D, 80.00 gram per dm cubed. Now, how do we solve this? We are given that we are going to start solving these by actually noting that we are given 200 cm cubed, and this is saturated with 0.4 gram of the salt. That is what is given here, that if 0.4 gram of it is obtained on the evaporation of 200 cm cube, meaning that 200 cm cube is actually saturated by 0.4 gram of the salt. Now, noting that, we can now say that 1000 cm cubed or 1 dm cube, which is actually what we'll take when we are talking about solubility, will be saturated by X gram. So now this very X gram that is going to give us the solubility, if you cross multiply, you are going to have that 1000, this 1000 times the 0.4 all over 200, and this will give us 2.00 gram per dm cubed. So this is the answer, and this is option B. So that's how you go about it. Why do we use 1000 here? We use 1000 because we know that the definition of solubility is actually that the solubility of a solute in a solvent at a particular temperature is the maximum amount of the solute in moles or grams that will saturate 1 dm cube. That will saturate 1 dm cube of the solvent at that temperature. So taking into cognizance of this definition of solubility, we can actually do this calculation that since we have 0.4 inside 200, what do we have inside 1000 cm cube or 1 dm cube? We actually have 2.0 grams. So actually, since we have 2.0 grams in 1 dm cube, we can say that the solubility is 2.00 gram per dm cube. Please, if you like this video, please hit the subscribe button by this side of your screen. Thank you for supporting us. God bless you. Like I said before, solubility definition is actually that the solubility of a solute in a solvent at a particular temperature is the maximum amount of the solute in moles or grams that will saturate 1 dm cube of the solvent at that temperature. So once you're given your parameters, you have to make it for 1000. So that any amount of solute that can be gotten in 1000 is actually the solubility. Hello, welcome. Let's look at this question. An acidic salt has option A, double anions in its aqueous solution, B, a single cation in its aqueous solution, C, hydrogen ions in its aqueous solution, D, hydrogen ions in its aqueous solution. Hydrogen atoms in its aqueous solution. So what is the answer? The answer to this is actually C. Hello, welcome. Let's look at this question for WAEC chemistry, number 6 question for 2018. An acidic salt has A, double anions in its aqueous solution, B, a single cation in its aqueous solution, C, hydrogen ions in its aqueous solution, D, hydrogen atoms in its aqueous solution. The answer to this problem is C, hydrogen ions in its aqueous solution. The reason is that an acid salt or acid salts are formed when the replaceable hydrogen ions in acids are only partially replaced by a metal. They are produced only by acids containing more than one replaceable hydrogen ion. So in this case, we are having, say, H2SO4 in aqueous solution plus KOH aqueous, and this will give us KHSO4 aqueous plus H2O liquid. So this is actually what we call an acid salt. This is supposed to be KSO4, but we have KH. You still have remaining H. You can see here we have 2H. So once there is hydrogen still remaining, we call it acid salt. And like I said, an acid salt is formed when a replaceable hydrogen, this hydrogen is supposed to be by this K, but you can see it's the only one that is replaced by K. The other one is still remaining here. So this one, because of this one still remaining, we say that this is an acid salt. So you can check the textbook for acid salts under salts. That is where you find this answer. So note that, very importantly, acid salts are formed. They are formed when the replaceable hydrogen ions in acids are only partially replaced. When they are only partially, so this is the replaceable hydrogen in the acid. So had it been there is complete replacement of this hydrogen, we'll call it, we know that we have normal salt, but it's only one that is replaced and one is still remaining here, so we'll call it acid salt. So whenever they are partially replaced by a metal, the metal replacing it in this our case is K, which is potassium. So that is whenever this happens, we have acid salt. Also, bear it in mind that they are produced only by acids containing more than one replaceable hydrogen ion. So take note, this one has more than one, it has two. So it must have more than one replaceable hydrogen ion. The acid must have, this is the acid, H2SO4 is an acid, this is the base. So whenever there is combination between an acid and a base, you're supposed to have a salt and water. But if the acid has more than one replaceable hydrogen ion that is not fully replaced by the metal, so you're still having hydrogen in the salt, we call it an acid salt. So that makes C the correct answer to this problem, that an acidic salt has hydrogen ion in the aqueous solution. This is the aqueous solution and this is the hydrogen ion. So this makes this the answer to this problem. Please, if you like this, please hit the subscribe button so that you can always, the subscribe button is around the side of your screen, so that you can always get our solved problems. Thank you. God bless you. Please, you can check in your textbook for acids, salts, and base. that is the topic where you see this. Check under acid salts. When you finish studying acids and base, when you get to salt, under salt you will see acid salts at types of salts. So that is where you get this definition and this notes that I've given. Thank you and God bless you.
This is how fast YouTube is with Brave. Notice how there's no pre-roll ads? And here's how you...
Welcome. Let's look at question number 7 for Chemistry WIAC 2018. A reaction is endothermic if the A. Reaction vessel feels cool during the reaction. B. Enthalpy change is negative. C. Bond forming energies exceeds bond breaking energy. D. Heat of formation of reactants exceeds heat of formation of products. So what is the answer to this question? The answer to this question is actually A. The answer is A. And why is A the answer to this question? The answer is A because for an endothermic reaction, the reaction vessel feels cool during the reaction. So why is this the case? This is the case because an endothermic reaction is one during which heat is absorbed from the surrounding. So if there is a reaction going on and heat is absorbed from the surrounding, then that surrounding has to feel cool. And the surrounding in this case is the reaction vessel. So let's take down the notes. An endothermic, this is the definition of an endothermic reaction. An endothermic reaction is one during which heat is absorbed from the surrounding. That is what an endothermic reaction is. So let's have reaction between these big substances and these small substances. So if you are having this reaction and you are having the environment as this very vessel, this is the vessel containing this. When there is reaction going on, from the definition of endothermic reaction, it is one during which heat is absorbed from the surrounding. That means heat is going from the surrounding, which is the vessel, into the reactants, or into the reactor, or into the reaction. There's movement like this from the environment into. So if the environment or the vessel is losing heat, it means that it will become cool. And that is for endothermic reaction. Now the opposite of endothermic reaction is what we call an exothermic reaction. And it is also good you know the definition. An exothermic reaction is one during which heat is liberated or given off to the surrounding. So that is exothermic. So you can find this topic in your textbook under energy and chemical reactions, so that you can be able to actually get this definition that I've given. So for every endothermic reaction, the reaction vessel, which is part of the surrounding, feels cool. For every endothermic reaction, the reaction vessel feels cool. It has to be cool because heat is absorbed from the surrounding. So if the surrounding is losing heat, it will be getting cold for every endothermic reaction. Please, if you like this, hit the subscribe button by the right hand corner this side of the screen. Thank you, and God bless you. Hello, welcome. Let's look at this question for WAEC Chemistry Past Question 2018, question number 8. In which of the following compounds does hydrogen form ionic compounds? In which of the following compounds does hydrogen form ionic compounds? A. CH4, B. HCl, C. NH3, D. NaH. So what is the answer? Is it in methane as option A, or hydrogen chloride as option B, or ammonia as option C, or sodium hydride? In which of the following compounds does hydrogen form ionic compound? So what is the answer to this problem? The answer is D, sodium hydride. That is the answer. So why is sodium hydride the answer to this question? It is the answer because the alkali and alkali earth metals like sodium and calcium form ionic hydrides with hydrogen, which have high melting points and are crystalline solids that conduct electricity. So when you check hydrogen and its compound in your textbook, you'll be able to see the fact that I just mentioned. And as a way of getting that note, you can write the alkali and alkali earth metals. Example is sodium and calcium. They form ionic hydrides with hydrogen. And the properties of these hydrides is that they have high melting point. I like giving you more points whenever I'm answering a question, so that even if you have questions coming, maybe another question might ask you the properties of the hydrides formed, so that from this you learn a lot of things. So that's why I don't just give the answer, but I also give explanation on other things surrounding the answer, so that anyhow you get the question, you will be able to answer. So that have high melting points and are crystalline solids that conduct electricity. So you might be getting a question, which of the following compounds have high melting point and conducts electricity? Then you should know it's also a hydride, like sodium hydride or calcium hydride. So the answer to this, like I told you, you can get this in your textbook under hydrogen and its compounds. Under hydrogen and its compounds. So if you check under hydrogens and its compound, you check the chemical properties of hydrogen, you're going to find out that it reacts with alkali and alkali earth metals, and those metals are metals like sodium and calcium. So it reacts with them to form ionic hydrides. So this is the ionic hydride or ionic compound, as it is asked in the question. You can see ionic compound. So actually it forms ionic hydrides. You can see this is the ionic hydride. So whenever this alkali metal or alkali earth metal react with hydrogen, so these ionic compounds have high melting points, and they also conduct electricity. So that is the answer to this problem. Please, if you like this, hit the subscribe button. The subscribe button is by this side of your screen. If you want to get more information on this very topic, check hydrogen and its compound in your textbook. Thank you and God bless you. Hello, welcome. Let's look at this chemistry question for WAEC 2018, question number 9. Consider the following reaction equation. Br2 reacting with Ki, 2Ki to give 2KBr plus I2. In this very reaction, this is bromine. So when bromine reacts with this potassium iodide to form potassium bromide, and you have your iodine molecules. So what is bromine acting as? Consider the following reaction equation. Bromine is acting as A, an oxidizing agent, B, a reducing agent, C, an acid, D, a base. So what is the correct answer to this question, considering the reaction equation given? The right answer is A. Bromine is acting as an oxidizing agent. And why is this so? It is so because in this very reaction equation, where you have your bromine reacting with the potassium iodide to give potassium bromide plus the iodine molecule. In this very reaction, we can say that it will be very easy for us to find out the oxidation number of the bromine. So we can easily find out the oxidation number of the bromine. So if we are able to determine the oxidation number of the bromine, we will be able to know whether it is increasing or decreasing. So the bromine oxidation number actually reduced from 0 to -2 in 2 kBr. We also noted here that it also gained or gains electron. And you know that that very substance that has its oxidation number reduced, or that very substance that gains electrons, is an oxidizing agent. So from definition, we can say that an oxidizing agent is one that gains electron. So the one that gains electrons and is reduced is the oxidizing agent. So that very reactant that gains electron is usually reduced is the oxidizing agent. We can also say that for the oxidizing agent, its oxidation number is also reduced. So its oxidation number is also reduced. So these definitions that I've just given can be found under redox reaction. If you check your textbook under redox reaction, you'll be able to see this. So take note, this is actually Br2, which is this. So this Br2 from this equation, the oxidation number of bromine here is 0, and it is reduced. The oxidation number of bromine here is -2, so there is reduction in the oxidation number. You know that for a single for a molecule on its own, the oxidation number is normally 0. Now if you calculate the oxidation number of bromine in this very compound, you find out that it's -2. So when moving from this reactant side to the product side, you see a reduction between the oxidation of 0 to -2. So once a reactant is having its oxidation number reduced, we say that that reactant is an oxidizing agent, and that's why we say that bromine is an oxidizing agent here, because the oxidation number is reduced from 0 here to this very place where it is -2. So once there is reduction in oxidation number, we say that that very reactant undergoing reduction in oxidation number is an oxidizing agent, because it gives its oxidation to the other reactant. So you check the oxidation number of the very reactant that you're talking about in the reactant side first. So if the oxidation number is reduced from what it is in the reactant side to what it is in the product side, you say that it is an oxidizing agent. So another property of an oxidizing agent is that it gains electron. That very substance that gains electron during a reaction, we call it oxidizing agent. So you can find this topic under redox reaction in your textbook. So please hit on the subscribe button, subscribe to our channel, so that you can always get information and solutions like this. Please, if you have any question, drop it on the comment section of this video. Thank you. God bless. Welcome. Let's look at this question number 10 for chemistry, WAEC. An organic compound has the empirical formula CH2 If its molar mass is 42 gram per mole, what is its molecular formula? Given H to be equal to 1.0, C to be equal to 12.0. A, is it C2H4? B, C3H4? C, C3H6? D, C4H8? So what is the answer to this? Now, for you to solve a problem of this kind, you should always note that the formula here is the empirical formula given, multiply it by n, it will give you the molar mass. So that is the formula. Empirical formula multiplied by n is equal to molar mass. So in this case, checking this formula will find n. So our problem will be to find n. So the empirical formula as it's given in the question is CH2. That is what is given. We are given that if this is the empirical formula, CH2. So multiply it by n, you will now get the molar mass, and the molar mass is given as 42. So that is how you solve this. And you know that C from what is given here is 12. So we can have C, in place of C we write 12 plus H. H from what is given here is 1. So in place of H you can say 1 times 2 because it's 2 times, it's going to be 2. Then close the bracket, n equal to 42. So 12 plus 2 is 14. So we can say that 14n is equal to 42. So that n is equal to 42 all over 14, which will give us what? 3. So n is 3. So, and we already know that empirical formula times n is equal. We also note that empirical formula times n is also equal to molecular formula. So that's another way of writing it. Empirical formula times n is also equal to molecular formula. So what is the empirical formula now? The empirical formula given is CH2. You can see it here, it is given CH2. So when you multiply it by n, you will get what we are looking for, which is the molecular formula. So if you now say that n is equal to 3, so what do you get? You will now have CH2 or bracket 3 to get the molecular formula. So if you open this bracket, you have C3. This 3 will go in C3. Then here we have 3 times 2. 3 times 2, so that you can now have H6. So this is the molecular formula, C3H6, because you're multiplying this 3 here, getting it into here, so it will give you C3. Then 3 now times 2 here will give you 6. So this is the molecular formula, and this makes option C the correct answer. So option C is the correct answer for this. So please take note of this formula. Empirical formula times n is equal to molar mass. Also, empirical formula times n is equal to molecular formula. So with this, you can simply solve this and you'll be happy you did. Please click the subscribe button on this part of the screen. If you have any question, drop it on the comment section. Thank you for your support and subscriptions. God bless you.
Install MakeTime to your browser and increase your productivity. It will be more pleasant to study and work. But how?
Hello, welcome. Let's look at this question for Chemistry WIAC 2018. Question number 11. Ethane is produced from ethanol by option A, decomposition, B, hydrolysis, C, ozonolysis, D, dehydration. So what is the answer to this very question? How is ethane produced? Is it by decomposition, dehydration, hydrolysis, or ozonolysis? Actually, the answer is D, dehydration. And why is it dehydration? Because when ethanol is dehydrated by hot concentrated tetraoxosulfate 6 acid, you get ethane. And this is actually the removal of one molecule of water from ethanol. That's why we call it dehydration, removal of water. So by explanation, I can have that the answer is actually dehydration of
Question 11 is that time.
ethanol. That's what gives ethane. And this is done using hot
Can it be question 11?
concentrated